then you can get a job as an AI chatbot.
You're absolutely right. Let me correct that for you. Let's try a different number. Well, that's funny. I did go on Amazon, Matthew. Do you go by Matthew or Matt?
I go by Matthew. And by the way, for the rest of you on this call, if you want, Ari and I can just chit chat and show that we both have failed careers as stand-up comedians, and we can just do that instead, if
Hey
everyone
now,
would prefer.
we're just gonna tell dad jokes. That's
Dad
why.
jokes.
That's how I failed.
That's where we go. Okay.
I ended up going on Amazon though, and I had a shirt made that says "You're absolutely right," and then I wore it around the office when I visited to see if anyone would notice what I'm making fun of. I did get one person. I did get one person, but I had to point it out.
That's a
I
great
was like,
t-shirt. Yeah.
it even has a star that looks like the Claude. You know. Anyway, all right. Without any further ado, I give you Matthew Hess. Matthew, looking forward to this. Thank you, friend.
All right. So I'm sharing some content.
And I'll interrupt you with any questions as we see
Yes,
them
please.
in the chat, so that you
And,
don't have to keep on looking at it.
and there's about 3 places during the talk where there's sort of a natural let's pause and make sure we got, we can talk about stuff. So you'll see those coming. So
Awesome.
yes, the talk is Much Ado About Nullable, and we're going to talk about nullable reference types. And before I jump into that, just a couple of acknowledgments that I always like to do. First off, I'd like to figure out if I know how to use PowerPoint. Okay, here we go. First off, I want to acknowledge my dad, Larry Hess. He passed away almost a year ago. And I just want to say I really lucked out in the father department. Daddy, I miss you every day. And I'm so grateful for everything that you gave me. So thank you to Larry Hess. I also want to thank my employer, CG Infinity. It's a good place to work. We're a consulting shop out of the Dallas-Fort Worth area. And they support these activities. They support the speaking I do. They sponsor the Albuquerque.net user group. Really appreciate all the support I get from CG Infinity. We are hiring, always kind of gently recruiting because we're consulting. And so we always need to build the pipeline. But right now, everyone wants on-prem. So you would have to live or relocate to Dallas or Houston to be considered. Okay, so to get into our talk, I've been doing C# a while. I'm sure a lot of you have. I actually got my start in Delphi, so moving into C# when I did was just natural because it's the same architect, Anders Helsberg, and I never pronounced his name right. I'm sorry about that. And so we've watched C# evolve a lot over the years. In C#2, we got generics. In C#3, we got object and collection initializers. In C#4, we got named and optional function arguments. Async await came in C#5. And in, basically since 7, a lot of amazing things, extension methods, tasks, lambda expressions, anonymous types, auto properties, tuples, pattern matching switch expressions. Really, the language has just grown a lot. And I think most people have been really excited about this. These are good features. They've made the language better. C# has brought in a lot of the best from other languages and adapted it. And basically, nobody has complained. It's been really great. However, in C#8 in 2019, the C# team launched this thing called Nullable reference types, which we'll just say has not been as universally praised and loved. It's actually been controversial and stirs up a lot of debate. And I've had this experience where if I'm at a conference or something and there's a few C# developers around, if I want to start a fight, I can just say, what do you all think of nullable reference types? And you'll get some very different opinions and very strong opinions on this. And I'll be honest, I kind of didn't really understand it. I was confused by it. I found myself just turning it off rather than trying to cope with it. And to me, that's always a signal. Like when I'm sort of avoiding something, that says, oh, you should probably take a closer look. I use that in my sort of creative process. Like, what do I need to be learning? So I took myself on kind of a deep dive journey to really understand this thing. What is it? What problem is it trying to solve? And that's what this talk is. It's like the result of that. So I'd like to take you through my kind of journey of understanding this. And at the end, I am going to critique it. I'll bring up a lot of the criticisms and critiques, and we can have some conversation about if you should use it and if so, how. But for starters, I think we just need to get grounded in really what it's trying to do. So why did they roll this out? Why do we have nullable reference types? And the purpose, in a nutshell, is to help prevent null reference exceptions. So what is a null reference exception? Probably all familiar with these. So here's a little code example to show it. I have a class called Polygon with this sides property and a static function called hello triangle, which accepts a polygon, P. And then you've got this line of code. If P.sides is equal to 3, say it's a triangle. So the problem here is P.sides. This is not null safe. If somebody calls hello triangle and passes in null, an uninitialized polygon P, then at runtime, you're going to get this system.null reference exception. Object reference not set to an instance of an object. P was null. That's a null reference exception. And the reason they're kind of icky is that they show up at runtime. So how do we prevent them? I mean, these have always been part of the language. So what do we do? And most of us just have learned to write null safe code. And it basically means you check for the null before you dereference the variable. So for example, this is safe. If P does not equal to null and P.sides is equal to 3, then console write line, it's a triangle. That's null safe, right? It has the guard here, the null check. And because C# Booleans are short-circuiting, if any component in a multi-step Boolean returns false, it doesn't evaluate the rest of the expression. So that's safe. Using null conditional syntax, which is a little newer, you could say if P question mark dot sides equals 3. So what that means is it's only going to evaluate sides if P isn't null. Both of these perfectly safe. And this is what we do, right? We write code that guards against null reference exceptions. That's just the way you're a good programmer. So here's an example with strings. It's important to remember that in C#, strings really are objects. They have some special handling that makes them behave a little bit like reference type, value types, right? They kind of feel like a value type, like an integer or a date or a Boolean or a decimal or a float, but they're not. They're pointers. And so this function, replace ampersands, is not null safe. It accepts a string, and then it does return s.replace, and it swaps out any ampersands for the word and. So the problem here, again, is that s might be null, and you would get a null reference exception. So then what do? Well, we write it with a guard. If string is null or empty, s, then return string.empty. That works. Else return string.replace. Or we can use the some null conditional and null coalescing syntax and do return s question mark dot replace. And then if that's null, if s was null, this whole left-hand expression is null. So you use this coalesce operator and return string.empty. So this is bread and butter, right? This is fundamental C# programming. No big deal. So still in all, I guess the problem is people still do write code like this, the upper example, the not safe examples. So wouldn't it be nice if the C# compiler could use its static flow analysis to warn us about these? We get warnings of all kinds of things. So here's an example of a warning that comes from static flow analysis. If you were to write int x like this, you'll see the little squiggly that appears and you'll get a warning. CS0168, the variable x, is declared but never used. And I'm sure we could list out lots of these, right? If you've used a method that has an async, it's declared as async, but what's inside of it does not contain an await, you're going to get a thing saying, well, it's marked as async, but it has no await, therefore it's going to run synchronously. You get that warning, and the compiler figures it out. Or if you've got code that's never referenced, it says this code is never used. So there's lots of compiler warnings that we get. So the idea here, the question I'm asking is like, wouldn't it be nice if the C# compiler could go back to those unsafe lines of code and say, hey, you have a possible null reference exception here. Check it and do something. So here is the challenge with that. The reality is that null reference types, they kind of come in two flavors. That's a Matthew term, right? This isn't like something you're going to find in a textbook or in the Microsoft documentation. So in the way I think of it is you have some of them which could be null and some that will never be null. So let me explain what I mean here with a few code examples. So the first one is an example of a could be null flavored reference. So polygon P equals shapes.find, and look for the octagon. So we've got this shapes collection. We're trying to find an octagon. Well, our shapes collection may or may not have an octagon in it, right? So it's extremely plausible that after this line of code, P will be null. And then if we launch right into this, int I equals p dot sides plus 1, that's not safe because we could be dereferencing a null here. So this is a problem. And this variable p could be null. Compare that to this next one. Polygon p equals new, creating sides equals 3 with 3 sides, int I equals p dot sides plus 1. This is totally safe. There's no world in which somehow p is going to get to be null between these two lines of code. Here is an example with a couple of examples with strings. So the first one is a could be null string. String s equals SQL data reader dot get string sub 0. And then if we do s equals s dot to upper, that could blow up. That's not safe. Whereas the string dot concat function actually is null safe, and it will never return null. It always returns either empty string or a string. So string s equals string dot concat, s equals s dot to upper is perfectly fine. You can do that. You could even just chain it if you wanted to. This is totally safe. So the problem is if we turn on some sort of compiler warning, it's going to warn us in all of these cases. And in the first and the third, the warning is good. It's welcome. It tells us something. In the second and the fourth, we kind of wish the warning would just shut up because we know it's not a problem. So the C# compiler has always had the ability to do this. It's just Microsoft chose to leave this up to the programmer. Basically, it's your responsibility. You need to write null safe code. Well, in C#8, they changed their stance on this. And they introduced the concept of variable annotation. So reference variable annotation. And what the annotation does is it gives a hint to the compiler about what your intention is, and basically whether the variable is a could be null variable that it should pay attention to, or a will never be null variable that it doesn't need to pay attention to. So the question mark means could be null. So here is an example of how you would declare in C#8 and later a will never be null variable. Polygon P equals new. So P will never be null. So we don't need the question mark. However, polygon P equals shapes.find, look for the octagon, should be declared with the question mark, with the annotation saying this polygon might very well be null. An example with strings. String s equals string.concat, fine, but nullable string s equals SQL data reader dot get string sub-0. So once we have given the compiler this additional information, now it can do a better job because you only get warnings on the could be null variables. So this first one, polygon P equals new, int I equals P dot sides, this will not generate a compiler warning. However, this one, polygon question mark P equals shapes dot find, int I equals P dot sides plus 1, that will generate a compiler warning. Notice that the line of code is identical. If you just looked at the lines of code, you'd be like, why does one generate a warning and the other doesn't? The answer has to do with how we've annotated the variable. Same thing with the string here. In the first case, s equals s dot replace will not generate a compiler warning. In the second case, s equals s dot replace will, because this is a nullable or could be null flavor of string. So this is the secret sauce that makes the whole thing work. When you turn this feature on, you're turning on two different things. One is you're enabling the ability to annotate. This question mark, you can't really add these until you enable the feature. You'll get warnings if you try to. And then the second thing is it's turning on the compiler warnings that then do the static flow analysis and try to find your possible null reference exceptions. So that's the secret sauce. That's what it's trying to do and how it achieves it. Now there's a lot more to say, but I want to just pause there for a moment and see if we have questions or comments or thoughts so far. This may be very different than what you were expecting me to say. Ari, we have any comments in the
I'm
chat?
checking. I had to stand up and walk over to the laptop. Anyone have any questions? None so far, and I don't see any in the chat, so I think we're good to keep going. Thank you, sir.
All right, we'll keep forging ahead. So the first thing I want to say is, and this is really important, this is not the same as nullable value types. And Ari, we teased you guys at the beginning. We're like, no, this was not introduced in C#3. That was nullable value types. And it's a totally different thing. And this is very confusing that they're named the same, but they are not the same. So let me explain why, what I mean by this. And so here is a class, my class, and it has public int, normal int, and public int question mark, nullable int. So this is the nullable value type that we started having in C#3. And then we have public string, normal string, and public string with a question mark, nullable string that we started getting in C#8. Now I wrote some reflection code where we get the fields in my class, and we just write out the field name and the data type. That's all this is doing, is just dumping the field name and the data type to the console. What's the output? Normal int comes back as type int 32. This is a typo, right? Should be nullable int is a type nullable tick 1. So you'll notice that, but even with a bool, this would be type Boolean. So it doesn't matter. What you notice is that an int and the nullable reference type, nullable bool or nullable int, they are completely separate data types. This is this special generic struct, okay? The nullable sub t generic struct that was introduced in C# 3. However, our normal string, what's the data type? String. Nullable string, what's the data type? String. So it actually doesn't change the data type. It just does something else, which we'll talk about here, right? But this is really important. I want to let that sink in. Nullable value types are separate data types. They completely change the data type. Nullable reference types do not. A nullable polygon and a polygon are both the exact same data type.
I do have a question about that one.
Yes, sir.
For the nullable value types, are those still stored on the stack?
Yes, they're structs. It's a generic struct. So structs are on the stack. Yep.
And then the regular nullable types or the nullable reference types just all heap. Got it.
Yeah, because they don't even change. There's no change to them at all.
Right.
They're stored the same way they always were. You declare a polygon in C#1 and a polygon in C#12, it's the same. Whether it's annotated with a question mark or not, always the same. Good question. Good question. Yeah, this nullable tick t is a struct. So it's a value, it's a value type. It's on the heap. I mean on the stack. Good question. So if it doesn't actually change the data type, which is what it kind of head fakes you into thinking, what is it doing? what are they? So what that question mark annotation does is it adds a custom attribute to the variable that's then used by the compiler. So the annotation goes on the type, but the attribute actually applies to the variable. And it's this custom attribute. So here's some more ugly reflection code, right? We're going to get the custom attributes dot first or default where the name ends with compiler services. So I'm fishing for an attribute with a name that ends with compiler services nullable attribute. This is very hacky, right? I just wanted to get some code to fish it out. Then if I got one, I'm getting its value, which is this nullable flags value. So we'll talk a little about custom attributes in just a sec, but we're getting the value. And then in my output, I am kind of this value is a bit flags thing. So I'm converting it out so we can get it into an integer basically and writing it out. So a normal string, the type is string and the nullable attribute flags value is 1. And a nullable string, the type is string and the nullable attribute flags is 2. So it adds this custom attribute and then the C# compiler can see the custom attribute and then it takes action based on that. So a custom attribute. Now this has been in C# forever. Lots of people are familiar with it, but maybe haven't stopped to think about it. So if you've done, say, ASP.NET programming, the things in the square brackets where you're like, this is my controller, this is my route, this is my, method. Those decorations, those are attributes. If you've done entity framework and you've hand coded maybe the data classes where you say here's a table, here's a field, I'm changing the name, in my object it's named this way, but in the table it's named that way. Again, they're in the square brackets. Those are attributes. If you've done JSON, customized your JSON deserialization with the JSON serialization attributes, that's another example. If you've done Azure Functions, they have all kinds of crazy attributes. So what does an attribute do? It provides metadata onto a type. It could be onto a class, onto a field, it can target different a parameter. It could target different things in your code, but it's adding metadata. And so anything that is dealing with attributes is using reflection. So when you build and deploy your ASP.NET project, the framework, the ASP.NET framework uses reflection to dip into your code, figure out all the routes, and then set everything up for you. That's how the magic works. Okay, attributes are just a very sophisticated, elegant way to build frameworks that can then leverage them to do work. Same thing with entity framework, right? How does it build the SQL? Well, it uses reflection and it goes and it looks at your classes. And in addition to just looking at the data types and the names, like the built-in metadata that you always have, it looks for any custom metadata that you may have added, which would change it a little. And then it does that, uses it to build your SQL statements. So in theory here, now this is totally fake, right? I just made this up. This is not how it works. But in theory, you could create an attribute. Public sealed class might be null attribute, which descends from attribute. And we're saying it targets fields and parameters. You can't have more than one and it doesn't inherit. So then I could say, hey, here is my class polygon with the sides, public static void hello triangle. And I'm going to say this is a might be null polygon P. So I'm saying that P is now decorated or has this attribute might be null. This is really what the question mark is doing. It's something like this. And Microsoft could have implemented it this way. Maybe they talked about it. And then that's basically a more kind of explicit way to explain what they did. Okay, so that's how this works. It's not changing the data type, it's adding a custom attribute, and the thing that looks for the custom attribute is the C# compiler. Okay, so we're going to talk about now getting our hands dirty and actually using it. But again, this is a natural pause point. Again, any questions so far? I hope I've blown your mind a little bit. At least a few of you are going, my gosh, I had no idea. When I first ran into this, I was like, this is not what I thought it was. I was quite surprised.
Anyone have any questions? Seems like we have head shaking horizontally.
Good. All right. Like the Indian chin wobble or the American head shake? Which one is it? Okay, just kidding. All right. So part 2, implementing null reference types. How do you turn this feature on and how do you use it? So you may already know this, but if you go to your CS proj, you'll find in this property group, you'll find a field called Nullable. And for anything after C#8, by default, this thing is added and turned on. So it's enabled by default. You do file, new project of any type, this will be enabled. And you can disable it. So this is a project level setting. And like I said, what it really does is it turns on your ability to add the question mark annotations, and it tells the C# compiler to go ahead, look for your annotations, and create null reference exception warnings. So when you turn it on, you're going to start getting a set of warnings. There aren't that many. You'll see there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them that I want to kind of quickly show you. And the idea here is point out the warning and also then explain the probably best way, or my opinion, the best way to address it. So the most common is CS8601 dereference of a possible null reference. That's your basic warning for the straight up null reference exception. So here we have a nullable string, S1, and then int I equals S1.length. That will generate a CS8601. But if we change it to int j equals, and actually this is a bug, right? It should be int j equals S1 question mark dot length or 0, we need to coalesce, then you would get no warning at all. That's safe. So basically what CS8601 does is it tells you to go do the null check that you should have done. This is the payoff. This is where you actually get the value. Polygon question mark p equals null, int I equals p dot sides, that's a problem. And again, it should be int j equals p dot sides or 0. So somebody caught this in an earlier version of this talk. And if you see other problems in my code, please point it out. That's the most common one that you'll see. So 8600 is converting a null literal or possible null value to a non-nullable type. I think of this as kind of a narrowing conversion problem. So I have a nullable string S1, and then I have a non-nullable string S2, and I'm assigning S1 to S2. That's a problem because this one might be null. So this is your narrowing conversion. You'll get a CS 8600. And again, if you just give it a null check and do the assignment to a string, that'll be safe. Same version with objects. Same thing here. CS8603, a possible null reference return. So I have a function, getName, that returns a non-nullable string. So let's say that the logic here is go look up some record by ID and return the name. And if no record is found, we return null. So that's going to do a CS8603 warning, where the function is advertising, I return non-nullable strings, you're passing back a null, that's a problem. The trick is to rewrite the function so that it just returns the empty string. And once again, here's the same thing with getShape. If it's guaranteeing you a polygon, you have to guarantee a polygon in the result. Possible null reference argument, CS8604. So here I have a function, print string length, which expects a non-nullable string. It wants either string.empty or a real string. And I'm calling it like this. I'm declaring a nullable string and calling print string length, passing that in. So this will give me the CS8604 warning. And I just heard Teams beep. Are we still on, or is there a problem? Did we have a service interruption?
Oh,
Y'all
no,
still there?
It was just somebody in the lobby.
Okay. Okay, very good. I just didn't want to be talking into the void for too long. I'm happy to do it for a while. It happens.
We're all still here.
Great. So anyway, same thing with an object. I have this function print poly sides that expects a non-nullable polygon. If I pass it a nullable polygon, it's going to warn me. So the best way here to resolve it, I think, is actually to modify the function itself, not all of the 100 or 1,000 places that call the function. What you should do is you should say, look, print string length actually accepts a nullable string. It can handle it. It's null safe. And then you modify the body of print string length to do something smart. Okay? See that? Similarly, print poly sides, just let it accept nullable polygons. Let it accept old school objects. And then you just put in your coalesce, you put in your check, and you make it null safe. That way, all the places that call the code don't have to change, right? Their logic isn't changed. And instead of changing 100 lines of code to squash this warning, which showed up in 100 places, you change 2 lines of code and it solves the problem everywhere. So that's a subtle, difference that I've made there. Sometimes the warning says change this exact line of code. Sometimes the warning says look at the call context in the larger situation and maybe handle things a little differently. Okay, you got to think a little. The non-nullable field property is uninitialized. This actually might be one of the most common ones that you would see if you turned this on for a legacy project, because many of us are used to defining these data classes. Sometimes they're called DTOs, data transfer objects. Sometimes they're called data models. Sometimes they're called POCO classes. Basically, they're simple classes supporting serialization. And it's often the case where we would say public string name get set. But that will generate now a CS8601. You have to go back and give them a default because a string, it needs to be set. It's not going to automatically be empty string as its default. Similarly, public polygon poly, this is a problem. You should initialize it is one way to solve it. Of course, you could also say, oh no, it's nullable. That would work too. But if it's not nullable, if this is what you mean, then you have to initialize it to shut up the CS8618 warning. In this case, starting with C#11, you can also use the required keyword, which is a very cool thing. So I could also say, instead of public string name get set equals tick tick, I could say public required string name. What that does is it makes it so that the compiler will check and enforce that you have initialized the variable by the time the constructor exits. So the constructor exits right here at the semicolon, right? That's the end of the constructor. So person P1 equals new, and then set the property initializer, Fred, name equals Fred. That's fine, because as we exit the constructor, including the property initializer, we have set a name. Similarly, person P2 equals new empty string, that's also okay. But if we say person P3 equals new and we either don't set name or we set name to null, that's going to generate CS8625. Most of the time, people probably just do this, but required is very cool. Second to last, CS8625 cannot convert a null literal to a non-nullable reference type. This is a little less common, a little arcane. But if we have this function, do something that takes a non-nullable string, and we say, do something null, that's a null literal, and we can't convert it to a non-nullable string. Same thing with polygon. Do something else, null, can't convert null to a non-nullable polygon. And here it's probably best to just solve it with annotation by making do something and do something else except nullables. The last one is kind of a bonus warning because it has to do with nullable value types, which is funny because those have always been there. Why didn't we have this warning starting in C#3? So if you do something like nullable int I equals null, and then regular int j equals I dot value, this now warns you basically that I could be null, and therefore I dot value is null, and therefore this assignment is going to blow up at runtime. So there's a little bonus bug. Personally, should have been there all the time, right? This is a good catch. But it has nothing to do with nullable reference types. It's the old nullable value types. So those are the warnings that you will start seeing. The last thing to mention in the context of implementing this is the null forgiving operator. So the situation this is meant to address is like this. There may be cases where a variable needs to be marked as nullable. Right? You need it that way for some reason. But you know that by the time a certain line of code executes, it will have been initialized. That the compiler can't figure it out, but you know that it's safe. So here's kind of a oversimplified example. I've got polygon question mark, so nullable polygon, poly. And then I have this program which calls init poly and use poly. Init poly instantiates the polygon, and then use poly does something with it, calling poly.size. So this will generate a CS8602, possible null reference, dereference of a null variable. But I know that use poly is never, ever, ever, ever called unless init poly has been called first. So I, the programmer, know this is safe. So you might think that's very contrived, but honestly, I've seen this kind of pattern a lot, especially in older object-oriented code where object models are complex and store a lot of internal state, and that state kind of gets built up a little bit. in UI frameworks, for example, graphing packages and other things, they're richly object oriented and they have complex internal state. And it's important that things they're obviously set as nullable because they're old, before C#8. And then it's just the way the code is written to make sure that things get instantiated. So it does happen. So what the exclamation point here, the null forgiving operator, lets you do is it basically gives you a one-line get out of jail free card where you tell the compiler, hey, just don't worry about this one. Int x equals poly bang sides. That will suppress the CS8602. It's almost like using a little pragma, right? To suppress you can use pragmas to suppress specific warnings, and you could say, oh, within these 3 lines of code, just don't apply the warning. It's almost like a variable specific pragma that you can apply. So it works. The advice is basically use sparingly and as a last resort. If you enable null reference, if you enable nullable reference types, and the first thing you find yourself doing is peppering your code with exclamation points all over the place, you've probably missed something. Okay, it's not ideal. All right, so the next topic I want to dive into here is
I did have a question about that.
Do we have a question? Yes.
Yeah, I do.
Please.
So would the normal compiler heuristics figure it out if no code paths would ever allow a null to be passed in?
Yeah, this is for the case where it doesn't.
Okay, so it wouldn't give you the warning if it sees that no matter how that code is called, it will always be
correct.
It'll always have a reference to something. Got it.
Correct.
Okay, cool. That's what I thought.
If the static flow analysis could prove it and figure it out, you won't get the warning. What I'm pointing out is that there are situations where it doesn't. That's all, right? There are situations where you wish it did, but it didn't figure it out. So what do? You don't want to rewrite your object, your code, right? You can just say, I know better. I'm the programmer. You're okay. Don't warn. And I suppose some future version of the compiler might get smarter and figure it out. But yes.
Right.
Exactly. That's exactly right. The answer to your question is yes. Good question. Thank you. All right. So, when you start a new project, it's enabled. Some of us just go disable it, but that's another topic. We'll talk about that in a sec here with the critique. But what if you are given or you're working on a legacy code base and you are told, hey, we need to make this thing use nullable reference types. Go ahead and enable it. So how should you approach that? And I'm going to contend that there are basically 3 approaches, one which I don't really love, one which I still don't really love, and one that I could recommend. So the first approach is bombs away. Just enable it, and maybe you'll get 100 warnings, maybe you'll get 100,000 warnings. I don't know. Just get out your hammer and start whacking the moles and pound away at it until all the warnings are gone. So the problem with that is, first of all, it can be just overwhelming. The psychology of it is horrible, right? You're just like, oh my God, I'm going to spend the next month of my life doing this for no point. And also, you might start suppressing the warnings in ways that aren't ideal. So you saw before where I gave you the example where instead of changing the calling function, everything that calls the function, you change the function itself. Well, if you've divided up the work, you might be responsible for the function call. Somebody else might be responsible for the function. And if you're not coordinating, you're not going to do the right thing. You're actually not going to make your code better and safer. You might just make more of a mess. So you can do it, but I think it might be frustrating and it might not give you the best result. File by file is interesting. So what this means is you go to the project, the CS proj, and you disable it. Then you go to each file you want to treat, and you can enable the annotations, which lets you put in the question marks without getting warnings. And you can enable the warnings, which will, for that file only, check and give you the warnings. So I think this helps some of the problem with bombs away because it at least narrows the scope, right? You can kind of contain the blast radius, deal with one file at a time. The problem is it really doesn't help at all with the situation where you need to be looking at multiple files to figure out the proper way to deal with a given warning. So it's better, but I still don't love it. What I recommend is what I call annotations first. You go to the CS proj and you, instead of enabling or disabling, you just set it to annotations. And what this allows you to do is go through the entire project and just audit your code and look at it and think about what it means and what the intent is, and then annotate it according to the intent of the code. So for example, let's say in your code base you had this string, public static, or this function, public static string double it, string s, right? This is pre C# 8. There are no question marks. This is just how it was written. And it was implemented if s is null or empty, return empty, otherwise return this. It's a beautiful legacy function. So looking at it, applying your brain, you can say, okay, this function actually accepts nullable strings. So I should change this to string s, string question mark. But it is null safe. It never does return null. So I can leave the return as a string. So I've made a choice here. I've annotated the function so that it actually says what you mean. It's your code intent. Similarly, let's say I have a class, public class person, which has a name string and a person parent object. And it just so happens that name is required. I never want to have a person without a name, but I may not know their parent. And so it's quite legitimate for that to be null. So what we do is we annotate person with a question mark. And because we're clever and we know which warning is coming, we say, yeah, and I'll give this a default. I'll head it off before I even turn the warnings on. So you see what I've done here. I've made code changes. They're small, but I've made some code changes that capture the intent. Now, when I turn the warnings on, project-wide or file by file, whichever you want to do, the warnings you get are going to be the legitimate ones that you really should pay attention to, the stuff you missed, rather than this wave of stuff that may or may not be important. So that's my recommendation, is you actually annotate and capture your code intent. Okay, so we'll pause there
So,
before the
question.
critique. Yes.
Yeah, I definitely have a question about that. So if you select annotations, what does it do for you? I mean, enabled turns
Yeah.
on the warnings, disabled doesn't.
So
And
if
annotations
you,
first, what am I going to
yeah.
see in the UX?
So if you have nullable disable, or you don't even have the thing at all, which is equivalent,
Yeah.
and if you go add a question mark after a type like this, string question mark, you'll get a warning saying you have annotated something in a context that isn't nullable at all. You'll get a specific warning telling you not to do that. You can't, so it's sort of not legal to add the question marks unless you have the feature enabled. But we don't want to enable the feature fully, so this lets us partially enable it. So when we say nullable annotations, it lets you go and add these annotations without getting warnings, but also without getting either warning, without getting the new compiler warnings, but also without getting the annoying warning that says you can't annotate because you don't have the feature enabled. You follow? It makes it legal for you to do the question mark thing.
Oh,
Just try it out. Just literally, just make a console app, okay, with like
you
a
still don't
couple
get
of
you don't get any of the warnings though.
correct.
So you
You
still have
get
to
the
read through your
you
code
you
and just
could, but you
decide where
can't.
you want to put it.
But when you put it in, that will cause a warning, specifically saying you added a question mark to a type, but you don't have the feature enabled. It's
Right.
am I making sense? You don't
Yeah,
it's a
no, I
different
get it.
yeah.
I get
Okay.
what happens. I'm just saying I don't get the benefit of seeing where I have my problem. It's it's the same
Not
thing as having
yet.
it but it's kind of the same thing
Correct.
as having it disabled.
Correct.
Well,
That's
I guess
right.
not, because if you disable it, you can't use it at all.
Correct.
But if you enable
Right.
it, you get
So
the warnings.
correct. You've got it. You've thought it through. So what I
Yeah, but
this is
then
sufficient,
with
right? This is a little odd, and it is documented. They
it
support this.
makes
They just don't.
sense.
They don't
It
really
makes
explain in the documentation. They don't explain like what purpose this serves. So to me, this allows you to do what I think is the 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 smart thing, which is let me just go annotate my code, then turn on the warnings and see what crops up instead of trying to solve these two problems simultaneously. Um, so try it. I guess at this point, I'm not going to start Visual Studio and demo it, although I'm
right,
tempted.
right.
But
I get
but I
it.
would
Yeah.
just just try it one more time for yourself, and then be like, okay, I get what this crazy man is talking about and why that could be helpful. Okay, yeah, these are my recommendations. You're under no
Yeah.
obligation to agree with me.
I'm certainly forming argumentative opinions, but I'm
No, no,
not
no,
gonna.
no. I love
But I get it.
it. I love it. Yes, as long as you understand the intent, right? Like what I'm suggesting, then you can decide if it's going to work for you. And it
So
probably
what?
has a whole it
Go
probably has a
ahead.
whole lot to do with the code base you're dealing with as to what approach works.
So if you have something like ReSharper, though, ReSharper might
Hmm.
be able to take care of that across the code base for you.
That's a great question. I actually don't know what tools can assist this very well. I haven't explored that at all. What I do know, for example, though, is Claude Code, which I enjoy using, often does it wrong. And then I've
Oh,
actually put some advice in my claw.md file explaining my
oh,
opinion on how to use this, how to use nullable.
Claude, Claude, please don't write bad code. Make site look
Yeah.
pretty. We do have
So
another question.
yeah.
I'll repeat it. Okay. All right, he's coming up.
Sorry. So
No.
we are working on a project right now where we are undertaking this. There are like 13 projects, I think, and we have kind of taken the bombs away approach.
Yeah.
Um,
Of course.
but we're doing it one project at a time. And the annotations thing is going to come in handy. I need to turn that on. I'm going to do that tonight when I get home and open up pull requests. But what we did, we have tried this a couple times. The first time was overwhelming. And so we decided to step back and try to approach it a little bit more systematically. And what we're trying now is we wrote a skill, a Copilot skill, that we have set out a bunch of, instructions for how we want it to approach making these changes. And we also told it, I worked with Copilot to kind of list out all of the different strategies for converting this code to enable the nullable reference types. And in the skill, we listed out a table of all the strategies. And we said, as you're making these changes, create a document that explains why you made the change that you did and which strategy you used. And so far, that has been pretty helpful. We're
You know
still
that That's
number
amazing.
2. But
Yeah.
yeah. And we also, we wrote another skill to write unit tests for all these projects. And so we're going project by project and making sure we've got pretty good unit test coverage on the whole project. And we'll do that in a one pull request. And the next pull request, we'll do the conversion, the nullable reference type conversion. So that we can see that those same unit tests that were passing are still passing, so that we know that we didn't change the behavior that much, at least. So that's been a useful strategy for us so far.
That's brilliant. And you know, I mean, whatever I would love, again, we'll talk at the end. We can connect via LinkedIn. If you're willing to share some of that, I know you may not, you may be restricted, but I'm not going to just slap it up in my YouTube presentations, but I would love to just, I'd love to learn and see what you did. That sounds like, what you're saying sounds really plausible, because what I've described to you here does boil down to there are certain kinds of warnings and certain kinds of strategies. It's not like completely open-ended. And it does seem like you could teach an AI to recognize certain patterns. So, or to kind of, that's brilliant. And I'm really glad you shared that. And I'm glad that if nothing else, I helped one person with one project. That, like, basically I feel like the meeting's over. I'm going to go home and crack a beer. We did it. That's the...
The annotations thing, right now, so we've done the centralized project build properties. So we have some shared stuff where we've defined some of the build properties for the project files. And we just have Nullable disabled there. So all of the project are disabled, and then we're turning it on project by project. But I am going to switch that from disabled to annotations. And I think that's going to make a huge difference, because we can start writing that more modern code without getting the warnings now in the other projects where we haven't turned that on.
And then my concern there is you've got almost a false sense of completion. Because once you turn annotations on,
you find some more.
And then you can always just hit enable and see what you missed. So I guess it's like
you can also go you can also do this: set annotations globally, do the annotation work, and then go file by file and turn the warning. This is like get the warnings file by file using the pragma. You see, you could use nullable enable warnings at the file level.
Go file
and
by
then,
file. So
and then once, right, and let's say there's 200 files in the project. Once all 200 files have nullable, have the warnings enabled, then that's equivalent to just now enabling it, and you can just search and replace, rip the pragmas out, and just enable it. So there's a few ways you can kind of do this a little more stepwise. So that's great. I want to keep going. We are pushing on here.
I'll reach out to you later tonight.
Fantastic. So that's great conversation. That's like, that makes my evening totally. Like that's why I do this. This is the whole point. That and to show off my really fun shirts. That pretty much my goal. So part 3, I want to offer some critique here. And again, I'm kind of repeating things that I've heard people say. I'm not necessarily saying I agree 100% with all of these, but I'll try to deliver them convincingly, right? So we can at least think a little bit. So, oops, boy, what just happened? So kind of the first and most obvious one is, well, they're still nullable, right? We talked about this. Nullable reference types like string or polygon aren't truly non-nullable. You can still set them to null. So if I were to do int I equals null, that just doesn't compile. But if I do string s equals null, it compiles just fine. Yeah, I get a warning. But they're not nullable. So, sarcastically, maybe they should have called this compiler assisted probably not null reference types. That would have been more, better for marketing the future. It's backwards. So C# reference types have always been nullable. How can you suddenly enable something that was always there? That's like I'm turning on oxygen. Oh, so wouldn't it have been better to kind of call the feature non-nullable reference types? Like point out the thing that's new. What's new is the ability to say that a string should never be null. And then instead of using the question mark to mark a nullable, which is now creates semantic confusion with null reference types, we use a star to mark the new thing, the non-nullable. So string S, which you always wrote, that would always mean what it always meant since C#1, which is it's nullable. However, string star S2 means this one is special. It should probably never be null. I think this would have been personally, a lot easier to explain and understand. This talk would have been a lot shorter. But, and I have heard from people that this was considered something like this. And for reasons that I don't know, it was not chosen. But that's one critique. So another critique is that it adds hair to C#. So one of the things about C# is it's always been very clean and elegant. It doesn't contain a lot of these complicated, fiddly little symbols with subtle meanings. I'm not a C++ programmer, but I believe both of these are legal C++, and they mean completely different things because of all the little stars and the positions and the fiddliness. So, C# avoided that kind of thing. But now with the question mark and the new use of bang, it's starting to grow some hair, some unwanted hair. A critique I've heard is that it kind of doesn't lead to better code. Basically, the idea is this. Most programmers learn early to write defensive code, to write null safe code. Does null reference types now give you this false sense of security? You don't need to worry about it anymore. The compiler will catch it. And therefore you write crappier code. Also, most programmers eventually learn to heed warnings. Sometimes we figure it out on our own. Sometimes we have a dev manager who enforces a policy that you can't actually commit your code or do the pull request if there are any warnings. One way or another, most professionals learn to pay attention to warnings. Is it possible in some cases that this floods us with so many warnings, many of which don't seem to be necessarily helpful, that people start to look for kind of the shortcut, the quickest way to suppress them or maybe even ignore them? If either of these were true, you could argue, well, maybe it's not really leading to better coding skills. It solves a problem that doesn't exist. So in theory, null reference exceptions are a serious problem. And it's true, if you ever see the null reference exception pop up in the middle of some program, it's really bad. It often, causes, it usually means your program is in a pretty bad state. But in practice, there are many huge code bases that rarely or never experience them. I worked on a project. It was greenfield. We wrote it from scratch. It had WCF and WinForms and just all kinds of cool stuff. And we never, ever, ever, ever got null reference exceptions. We had other bugs, but we just wrote clean code. We had coding standards. We had code review. We had the processes and practices in place to prevent them. So was it really necessary to add all this complexity to address something that's kind of more of a theoretical problem? I've heard that. So it's a half measure. It's true. Newer languages like Swift, Rust, and Kotlin, they actually have true non-nullable reference types. In Swift, for example, string and string ? Are actually different types according to the compiler, and only string can be nil. When C# was launched in 2002, this was not the norm. Back then, our high productivity languages, Delphi, Java, Visual Basic, they all assumed that object references could be null. They added incredible convenience and safety, right? Versus pointer dereferencing and things you had to do in C++. So they made objects a lot more usable, but there was never the idea that they weren't pointers, right? They were heap allocated pointers and they could be null. This was just understood. So is now C# kind of wishing to go back and rewrite history? So, if that's the intent, the current implementation is a half measure because the reference types are still nullable. It goes back to that other critique, right? They didn't really get you to what you have with Swift, Rust, and Kotlin. It overloads the question mark symbol yet again. So I get it that null reference types is not 100% responsible to blame for this mess. But at this point, we have now there's a seventh I don't think I even have in my slide. 7 different uses of question marks to do different things. And I'm sure you will agree, it would be nice in a language for a symbol to mean one thing. Plus plus doesn't have multiple meanings, right? The equal sign doesn't have multiple meanings. But here we have the ternary conditional operator, which is the original use of the question mark. And then the nullable value type in C, I guess it's C#2, not C#3. The null coalescing operator, the null conditional operator, and then nullable reference types annotations, and then the null coalescing assignment operator. Just all of these different uses of question marks. And I don't know. I'm not a fan of the same symbol having so many meanings. So the last thing is that even though people are using it and implementing it and deploying teams to deal with it, nobody actually understands it. So it took me an hour here to explain this to you, right? I filled an hour talking. Can you imagine if it took me an hour to explain value tuples or lambda expressions? So those are also complex and powerful features, and they have some subtleties to them, like variable scope with lambda expressions is not obvious. Value tuples and equivalence handling is not obvious. There's some subtlety, but it would not take me an hour to talk about it. So if the purpose of this language feature is to make the language simpler and safer, I'm not sure. It maybe it instead is introducing ambiguity, complexity, and in some cases just confusion. So I don't know if it fits well with the long-term spirit of C#, which has always been extremely, relative to other languages, simple, safe, and elegant and expressive language. It lets us all focus on the business logic, right? That's the point. So here's the counter criticism. Matthew, you're just grumpy. So, okay, fair point. I admit it. I'm old-fashioned. I wash my car by hand and I dry it with a chamois. I cook exclusively in cast iron. I don't do coffee flights. I won't put truffle oil in or on anything. So maybe I'm just grumpy. Maybe I'm just being a curmudgeon, and that any of my resistance to this is just basically resistance to change. It's a fair point, and that could be true up to a point here. So where does that leave us? Little wrap-up slide. What should you do? So I think we can say it's not perfect. Okay, this thing does involve a series of compromises. It is not possible to go back in time and redo the language. So they made some choices and some compromises, and we just have to understand them. I do think it addresses something real. Okay, I think null reference exceptions have continued to be a bit of a problem. And when done right, I do think this thing has the ability to make our code better. Should you use it? So for projects which are kind of an island, in other words, you've got this code base, it's yours, nobody else is using it. I really think it's a legitimate choice. If this feature works for you, go for it. If not, don't feel bad. Just disable it and write your old classic C# code. As long as you're kind of the only consumer, it's not a problem. However, for shared projects, or those in the public domain, like if you're writing libraries used by other people in your company, or if you're writing NuGet packages that are used by people you don't even know, I think you're on the hook here. You need to enable null reference types because those people who use your code will expect it to be kind of null reference type savvy. And when this feature first came out, one of the big frustrations was, all of the supporting libraries that we use, even the Microsoft ones, had not been annotated yet. So there was kind of this weird interrupt, this impedance mismatch where I'm trying to write code that uses null reference types and I'm calling into code that has no clue what I'm doing and everything is means different. So that has very much been sorted out since C# 8, at least in the public domain. And now many, private domains of shared libraries, like our friend who asked the question earlier, are tackling this. So I don't think you have a choice in some cases. And for legacy projects and also for new code, I guess remember to annotate first. Think about the annotations as just part of your literate coding process. And it makes you focus on the meaning of your code rather than just chasing warnings. So that's my advice. All right. So feel free to, I swear this doesn't take you to a crypto wallet or something malicious. So feel free to connect on LinkedIn. I have a YouTube channel at C# Artisan. I think I'm up to 70, 75 videos, all different stuff. Async await and Azure Service Bus, kind of a lot of different topics. It's been a bit since I did a new video, but if you don't find me completely annoying, if you like my style, you'll find some other content there. Please do like the videos, please subscribe and do all those viral things. I don't make any money off of it. It just helps, it helps other people who share your interests kind of find the content more easily. So I appreciate that. And with that, we'll open it up for last questions and discussion.
Any other questions? Questions? Q&A? I would argue with you that there's a number of operators that are overloaded a ton. I mean, even the minus symbol is used in a bunch of places, and then plus, and minus equals. Yeah, you can override them yourself if you want. You got minus by itself. And minus is a negative to cast something to negative. It's I mean,
Yeah.
And I was thinking about the difference between something like Swift, where string question mark is true nullable string as a reference type, and then string itself can't be nullable. Well, I mean, the only difference it seems with C# seems to be they treat it as a warning instead of an error, which seems like a compromise. Like, as you transition, you can move over and have better code if you want, and you can live with the warnings to know that you should have better code. But I think it all depends.
I think that's
You
well
can
said.
treat warnings as errors too, right? And if you want to have the Swift version of it, just treat warnings as errors. And
although
would be cool.
Still you can still write code using the null forgiving operator. You can still write code that will assign null to a non-nullable string. You can still make it happen.
Oh yeah. I mean, you can
right.
You can do anything you want when you want to make a bad decision.
Well, right, but when I guess this is what we're talking about here is, yes, there's some compromises here. There's a little bit of nuance. It's not just so clear cut. I agree with your analysis. And
I think when you're dealing with like external systems, it makes a lot of sense that, I mean, null is a fact of life when you have to work outside of your system, because you might not get the data that you need. It's just the way it is. So anyway, I'm off my soapbox.
No, it's good. Other questions or comments? Experiences people want to share?
I actually, for some reason, I'm glad you pointed out that the null forgiving operator, I thought I could use that in a type declaration to say this can never be null. But I'm not sure I ever tried that. So in my head, I thought that was a thing. But I guess it's not. It's the opposite. I'm saying I'm gonna commit, literally, and figuratively, that this will never be null.
Right.
And-
You
and
don't
then-
worry.
and then-
It's yeah. The type tells you it could be null, but I'm saying no, it actually won't be. Don't worry. Don't warn. Exactly. Yeah, see, again, it's a little complicated, right? Like
Yeah.
I don't think I'm not a dumb guy, you know, I'm reasonably bright. Okay, and this took me a bit to be like, what on earth is this actually doing? And I had to go
Yeah.
remove a bunch of exclamation points from earlier code. Because I didn't get it
Yeah,
at
true.
first.
Yeah. It's almost like, the exclamation points, like the middle finger to the compiler saying, no, you trust me. But
That's
it's
funny.
like, well, man, I warned you, so cool. You want to go put the bang down there, then don't be surprised when it goes bang. Cool.
All right.
Well, I think we're
stuff.
good on questions. Matthew, that was a fantastic presentation. I know a lot of people got a lot out of it, and it sounds like you're going to make at least one new LinkedIn connection. And gosh, I hope we get to have you back again. It's always a pleasure.